So this is the 2014 Junior Cert High Level Paper 1 and we're looking at question number 6. Below are 3 containers labelled 1, 2 and 3. Water is poured into each container at a constant rate until it is full. So we have our 3 containers here. The 3 graphs A, B and C show the height of the water H in the containers after time T. So our graphs have H up the y-axis and time going by across the x-axis. So as time goes by, what happens to the height as it's being poured at a constant rate? That's important. Constant rate, so the same amount of water going in per unit time. Okay, so what are we asked to do? We're asked to write A, B and C in the table below to match each container to its corresponding graph. So we're matching the containers to the graphs. Okay, so graph A, we can see as time goes by, the height is increasing at a constant rate. The height is increasing at a constant rate. So that would match container 2, because container 2 is the same width, this hexagonal shape, all the way up as it's being poured. So the height is going up at the same rate as the water is going in. So container 2 is matched to graph A. Okay, graph B, you can see as time's gone by, the height is going up at a certain rate, and then all of a sudden the height goes up faster. So we can see, if we look at the diagram here, container 3, this kind of cylinder, smaller cylinder on top of a bigger one, would fill up at a certain rate up to here, and then once it goes into this smaller cylinder, the height would fill up faster. So that's why we have this change at this point here in graph B. So graph B is matched to container number 3. And that leaves graph C to match container number 1. And we can see there that as container number 1 is quite wide at the bottom and then gradually getting narrower as we go up. So this starts to curve upwards with the height filling in quicker as you go, or the height rising quicker as time goes by. So C, A, B. Part B, another container is shown below. Water is also poured into this container at a constant rate until it is full. Sketch the graph you would expect to get when plotting H against time T, height H against time T for this container. So for this container here, it would start off, as it's gradually widening, the height would be rising quite quickly and then eventually slowing down. So the curve would look something like, starting from here, be a smooth curve, going something like this, slowing down as you get up towards the top. So some curve there, gradually smoothing off in that fashion. That's the end of part B and the end of the question.